Good day everyone. Welcome to our midterm coverage in our subject Algae Physics. So in this midterm, we will going to discuss all about motion, on how motion is being described by the different scientists. Okay? We have the ancient scientists, we have Aristotle, Galileo, and also we have Newton. First thing was um, Galileo and Aristotle have different description on what is motion. According to Aristotle, who was one who described the behavior of an object in motion, where he described it as objects with heavier mass fall faster than lighter objects. So the meaning of this is the heavier you are, the faster you move downward, and the lighter you are, the slower you move downward. Just like for example, if we have a stone and a feather. So if you're going to drop these two objects at the same time, obviously the stone will going to reach the ground first. Okay? But according to Galileo, okay, regardless of the mass of the objects, they will fall at the same time, neglecting air resistance. So these statements of Aristotle and Galileo led into the further description of motion by Isaac Newton. Actually, Aristotle and Galileo have correct and accurate observation, but there are limitations. Okay. According to Aristotle, mass is uh, a mass is a factor contributing on the motion of an object. But for Galileo, mass is neglected, or mass is not a factor contributing on how objects behave during free fall. But for Galileo, he disregarded gravity. So, in short, according to Galileo, is objects, whatever their masses is or masses are, they will fall at the same time at the same rate. For Newton, there is a story regarding on how Newton have described motion, okay, which led him to have the three laws of motion: the law of inertia, the law of acceleration, and the law of interaction. Okay, so in here, according to the story, when Newton is thinking on how he will going to describe motion, he is sitting under an apple tree. I don't know if it is an apple tree. Okay, and then suddenly an apple fell on his head, and now he concluded that the behavior of the apple has something to do on how he will going to describe what is motion. So these are the early ideas of how object move or how motion is being described. Okay? So motion will be described as we go on in our midterm coverage. But for today, we're going to describe how fast and how slow an object is. And that is what we call speed and velocity. Now, in the following video, I will going to show you a video coming from YouTube on how speed and velocity differs from each other and how problem solving is being solved. So let's watch this video, and I hope you will going to take note everything that is very important for us to better understand the concept of speed and acceleration. Okay.
Hello everybody, today I'm answering an email that I got from a young physics student while I'm working on an array of really cool videos that I'm sure you guys are gonna like. So the question is, what is the difference between speed and velocity? That is an interesting and excellent question, because I too at some point thought they were the same thing. Now, as per usual, I'm gonna tell you what the difference is in words, and then I will explain it with an easy example. So basically, the difference between them is that velocity has a direction while speed does not. In physics, we call speed a scalar quantity, while velocity is a vector. Now that means that if we take this expression 30 kilometers per hour, just like that, now this is speed, because it says distance over time. So this is by definition speed. As simple as that. But for velocity, now this expression would look something like 30 kilometers per hour in the north direction, or due north. Now let's take a look at a very simple example. If you took your bicycle and you want to go to the park, if you're riding your bicycle at 5 kilometers per hour until you reach the park, then your speed is 5 kilometers per hour. Is the distance that you have covered in the time it took you to cover it. But for velocity, like I said, it has to do with the direction. So for example, if you start from point A and you go with that speed in a circle and then you come back to point A again, the exact same point, then we say your speed here is 5 kilometers per hour, but your velocity here is 0. And the reason it is 0 is because there is no directional gain. You started in the same point and then you came back at the same point again. Even if you were to walk 4 meters this way, 2 meters this way, 4 meters this way, and then 2 meters up here, then your velocity or average velocity is 0 kilometers per hour. The difference between the two is like the difference between distance and displacement, basically. If you're not sure about that one, comment below and I will make a very quick video like this about it. Thank you so much guys, just a quickie today while I'm working on different videos that are longer, and I will see you on the next one.
So the video has given you the difference between scalar and vector quantity. Now the next video will teach you how to solve problems regarding speed and velocity. So please watch this video.
G'day and welcome to the Tech Math channel. What we're going to be having a look at in this video is we're going to be looking at calculations involving speed. These are ones where we would either be working at, say, how fast something was going in terms of, say, kilometers per hour or miles per hour, given time and distance, or maybe we're working at distance calculations or time calculations, so everything involving speed, how far and how fast and that sort of thing. Now I'm going to assume when we're doing this that you don't know very much, okay? So we're going to be going through these and I'll show you a few good little tricks. Now this is my really bad drawing of a car, and I've drawn this on here for a reason. Not to show you my astounding art skills, which I know they are incredible. But what I'm actually looking at with this is the thing most people understand with speed, okay? Because you're driving down the road, and quite often you see and quite possibly pay attention to these particular signs, okay? And they'll tell you how fast you should be going, okay? Speed limit signs. Most people know this, okay? So speed is, okay, this is the speed we should be going. I'll even write that down. Now speed should be equal to 60. Now 60 what? And most people do understand, if you're in Australia, it means 60 kilometres per hour, or if you're in the States you might call this 60 miles per hour. But straight away we have got ourselves a formula, okay? I'm going to rub this 60 out because it's sort of irrelevant. Well, the police might not say that, but you're going to see here that what we have is we have a distance over time, okay? So speed is equal to distance, okay, over time. This might be miles per hour or something like this. So I'm going to write our formula down here. Speed is equal to, and I'll rub that out, So when we do this, we're going to say distance over time. Look, I'm going to leave that car up there for the minute, just to, so you can all bask in my great artwork. But you see, this will be something like kilometres per hour, or miles per hour, or metres per second. I think I've laboured the point on that one. So you should know the formula. It's a really great way of remembering this particular formula. Okay, so the type of question you might get asked with this is, say you might say, what is the speed of an object, what is the speed of a car if it goes, and you'd be given a distance and you'd be given a time. So let's give you one here. Say we were given a distance of, it went, let's say 120 kilometres, and it did this in a time of, let's say 5 hours. It was flying along at, no, it's not very fast at all. So how would we work out what speed this car slowly went down the road? Well, we'd go distance over time. Distance, which is 120 kilometres. Again, for this particular one is kilometres, over a time of 5 hours. Okay, so 120 divided by 5 is equal to 24. 24 kilometres per hour. Okay, so kilometres per hour. Kilometres per hour. Okay, so hopefully you're good with these. And this doesn't matter if you're talking about miles per hour, it's the same formula. If you're talking about metres per second, it's the same sort of thing. Okay, it's just our units over here are going to change then. Okay, just one thing to be careful of with this, and that is a bit later on, you will want to watch these units, and I'll give you a heads up when we're doing these. So that's all well and good, and that's if you want to work out speed. But say we were given a speed and we were given a time, and we wanted to work out the distance something had travelled. Say we were given a time. Say we were given a speed and a distance, and we wanted to work out the time. We were given a time and a speed, and we wanted to work out the distance. How would we do this? Well, I'm going to show you a little way of being able to change this formula around, and this is not involving anything dividing by this or timesing by this and then moving that over there and moving this over here. I'm going to show you a far simpler way of doing this, and that is through this idea. First off, you draw yourself a triangle. Okay, this is my triangle here. Isn't it beautiful? I'll put a T right in the middle of it, and we're going to be using that T because I'm going to write this, our formula here, our speed equals distance over time. Do you see that? Speed is equal to distance over time. Also, look, I know this is hard to do, but I am going to rub out this car. Okay, what happens if we wanted to work out, say, time? A time calculation. This would be equal to, and I'm going to put my thumb over the top of this, and you're going to see that we have the distance is over the speed. Time is equal to distance over speed. And that is true. Okay, so distance over speed. Okay, how's that for you? Pretty good. Say we wanted to work out, in fact, what about first off, I give you a example of this. So say we were given a distance that had been travelled, which was 1,000 miles. I'm not actually sure how to abbreviate miles. We don't tend to use them over here in Australia, but anyone wants to tell me, I'm not sure. I sort of feel uncomfortable using them. That's how we abbreviate metres over here. But we were doing a speed of, say we were doing, I was better to say 110 kilometres an hour, but say we were doing a speed of 60 miles per hour. How long would this take? So we would use our formula here, and we would say that our time is equal to this distance, which is 1,000 miles. I'm going to abbreviate to M. I'm probably going to be doing totally wrong there, but it does. Okay, over the speed, which is 60 miles per hour. Okay, now the answer to that, if we were to do this, is 16.6. Now 16.6 what? You're going to see here that this and this cancel each other out, so we're left with hours. Okay, and it makes sense. Okay, this is a time measurement. We've got our measurement in hours. Okay, and just be careful when we've ever got these particular decimals involving time. This doesn't mean, this is actually 0.6 of 60 minutes. So just be careful of those. Anyway, what about we now work out a distance measurement? So hopefully that's pretty good. So let's have a look at a distance measurement. So I'll get my lucky red pen, and I'll go distance. And this is equal to, okay, distance, I'll put my thumb over this here, my yellow pen, and I'll say that it equals this speed times time, okay? So distance equals speed times time, okay? Speed times time, okay? So say we were given a speed of, what about we were doing 100 kilometers per hour, and we were given a time of 30 minutes. And I've chucked this in here to be a little bit confusing here to show you a little pitfall here. Now, first off, what you're going to notice is we can go this times this correct. No, we can't. And I'll tell you why. Because our biggest problem with this is our units are not the same here. We've got time measurements where they're in different units. Now, we have to get these units the same before we start. So, I'm going to change this into hours. So, 30 minutes is how many hours? And you're going to see that it's half an hour, which I'm going to write as 0.5 hours. Okay, so our speed is equal, not working at speed, what am I doing? Our distance is equal to speed times time. So speed, which is 100 kilometers per hour, and this is times 0.5 hours. Trying to squash it in my work there. Okay, so with this, what are we going to do now? We're going to multiply these guys out together. So 0.5 times 100, and we're going to get an answer of 0.5 times 100 is 50. 50 watts. Well, you're going to see that our hours cancel each other out, because this is dividing and this is timing at the time. So we're just going to end up with kilometers. Okay, so our distance is 50 kilometers. So hopefully you're fairly good with these. Okay, so there's a couple of things to remember: that how to work out those distance over time type measurements, but then how to change them around, and then it's just a simple matter of plugging things into a formula. Anyway, hopefully you understand that, and hopefully it's really good. Any questions, comments, as usual, please send them through. Anyway, take care of yourself. Bye.
So that's it. So if you have more questions, just beep me in the messenger, or send me an email. So I had given you my email, and I know also that you know my messenger account. So thank you for listening. So I'm hoping that you had understood what is being discussed for today. Okay? So thank you so much.